Welcome back to the Art of Math. In the previous videos we went over applications of the quadratic equation, and in this video we'll go over a very common, very useful property dealing with the sum and product of the roots. So the breakdown of this video is going to sort of follow this part over here. Okay, so first part is who cares? So to recap, here's a quadratic curve, which is y equals ax squared plus bx plus c, and the arrow just mean they correspond to this plot, which is this U-shaped looking parabola. Now, if we want to find where this curve hits this x-axis, we'll set this same thing equal to 0, and by trying to solve this, that'll give us these points. Okay, so the beginning point of this video is sort of in this step here, where we're dealing with these points. So what is this business about the sum and product of the roots? So there's a few situations. So perhaps we know one of the roots, and from that we want to figure out what the other root is. Or we just don't want to find the roots altogether, and we may wonder, hey, is there some nice property? Are these somehow related? Can we come up with some ideas for what, there might be something nice about them. Okay, so that's sort of who cares. It's not the most maybe fascinating thing ever, but it's a natural question to ask in just playing with these things. Okay, so from there, we're going to divide by a. So we're going to have x squared plus b over ax plus c over a equals 0. So we just divided everything by a. Why do we divide by a? Because it makes our life easier for this next step. Alright, so here's the key step, and this is the key concept in the video. I circle this in red, and there's an unhappy face or angry face, because when I was learning this a long time ago, this is the step that tripped me up the most. So if you get nothing else from this video, there's these things that you can memorize, we'll get into, but the main thing I want you to understand this step right here. If you got this step, that's the key thing. Okay, so once you get to this step, if you remember quadratic equations, the quadratic formula, two things can happen. Either this factors nicely into something like this, or it doesn't factor nicely, and you may have to use the quadratic equation. The key step is, even when this does not factor nicely, there still is a factorization. So it may not be like 1 and 2, it may be square root of 7 plus 5 over, it may be really ugly numbers. But the point is, even when you're going to have to use this formula, if you, from some divine way, you could know what the roots are, you could just still factor it, except in practice, you're never going to figure these out if these aren't nice numbers. Okay, so this can always be done. That's the key point. Not just when it's nice, but even when it's ugly. So we're conceptually going to assume that we know these roots. So R1 and R2 represent the roots. So these are the same R1 and R2 that you would get from using the quadratic formula. So you may be a little confused with the notation. So what's with the x's versus the r's? This is the general x. If you set x to either this first root value or the second root value corresponding to these solutions here, then you would zero this out. Alright, so assuming we knew what these are, we could break this down this way. It's x minus something times x minus another something. Now this is a very important property. So let's say instead of quadratic, instead of this being second power, this said the 7th power or 8th power. So if this said the 8th power, then we would just have 7 or 8 of, for 8 we would have 8 of these terms. So it would be x minus r1 times x minus r2 times x minus r3 all the way up to x minus r8. So this is a very, very important, I'm going to stress this, this is very important to understand this step. Okay, once we do this step, which is a hope that we could somehow factor this, we're going to multiply this out and expand. So if you multiply that out, x times that, this times that, you're going to get this. Now, once we group these two terms, you're going to have, they both have a minus, so I factor the minus out. You have an R1, R2, I just reverse their order. So if you multiply these into the x, you should recover these two terms. So we just group this because it's nicer, it's easier to remember this way. So here's the key thing. That stayed the same, we just rearrange this. The blue corresponds to the blue, the green corresponds to the green. So the most obvious sort of superficial point that most of you, or probably a lot of you, want to know is, what are these sum and product of the roots and how do you get them? So here they are, here are the formulas, but I don't really care that you memorize these. You should know them, but here's how you get them. So we compare the original over here with this part over here. So negative, and what is R1 plus R2? That is the sum of the roots. What is R1 times R2? That's the product of the roots. So the product of the roots is this C over A term. And the sum of the roots negated, so the negative sum of the roots is B over A, or if you think of it another way, the sum of the roots is negative that. So that's where we got these two things, by just comparing them. So this is a very, sort of like the second most important thing, which is related to this, the concept of pairing them off. So this x squared goes with that x squared, and whatever this coefficient is has to be this other coefficient. So you may be wondering, why are we doing this? Well, without even finding the roots, we know something about their sum. Without even knowing the roots, we know something about their product. So let's do an example. So for example, you have this quadratic equation right here. I've picked nice numbers so we can work it out without the quadratic formula. So we'll divide by 2, and then voila, it factors nicely. So from here, we could see that x equals 1 or x equals 3 will make this 0. So we can manually check that if you add 1 and 3, you get 4. If you multiply them, you get 3. So the sum of the roots better give us 4, and the product of the roots better give us 3. So let's try to use these formulas. So the sum of the roots is negative b. What's b in the original? It's negative 8. Make sure you don't forget that minus. So that's why I circled the plus and the plus. That's why these signs are part of the circled things and not just the letter stuff. So the sum of the roots is negative 8 over a. So that's 2. So that turns into positive 8 over 2 is indeed 4. So 1 plus 3 is 4, and that's 4, so that's good. Now, the product of the roots should be c over a. So c is 6, a is 2, 6 over 2 is 3. And if you remember, 1 times 3 is also 3. So this works out. So how would you be using this stuff? You would just memorize these two things here. And when you see something like this, without finding these x's, you can go straight from here to here. So that's the application part. So we went over one derivation. The 2 means there's 2 ways to do it. The traditional and sort of the fundamental heavy-duty approach is going the way we've gone here. But you could also do it another way. So you could say, hey, I know the quadratic formula. So what happens if I just add these 2 roots? So take negative b plus the square root business over 2a, and then take negative b minus square root of that stuff over 2a. And if you add them, the plus and minus square roots cancel. So you'll have negative 2b's now over 2a, which is just negative b over a. So that proves the sum of the roots in a different way, directly from here. And now this one's a little more annoying, but if you take these, one with the plus, one with the minus, and you multiply them out, you'll have a lot of cancellation. So once you multiply them, you'll have a negative b times a negative b. That's going to give you a b squared. And that b squared is going to cancel with that inner b squared. So it'll look pretty nice. And eventually you'll get this. So that's actually a pretty good exercise you guys may want to try, which is derive this by multiplying these 2 roots out. One with the plus, one with the minus, and see if you can get that. All right, so that's the second way to derive these 2 rules. All right, so again, the key concept is understanding that we can conceptually factor this. Even if we don't know how to factor it, we can just write it out this way. And by thinking about this thought experiment, we've come up with these nice little rules. Okay, and then from there, we're pretty much done.